Howdy, 8th grade. Today we're going to talk about how to identify this new thing called quadratics. So far, when we're dealing with a lot of equations, most of the equations we've been dealing with are linear. And today we get to start looking at this new kind of thing called a quadratic equation, which often looks, just so you see what it looks like, would be y equals x squared plus 4x plus 9 or something like that. And this right here would be the quadratic part. So quadratics take the form, or look like, take form as a fancy math way to say look like, ax squared plus bx plus c, where a, b, and c can be anything. I want to show you guys a little bit what this looks like. So I'm going to graph a quadratic real quick just so we can look at it, and the quadratic I'm going to graph is y equals x squared minus 4x plus 3. So give me just a second and I'll get this graphed. Alright, so this is what the graph of y equals x squared minus 4x plus 3 looks like. So basically what we have here is a parabola is what it's called. Write that down, parabola. And that's just the way we describe this bowl shape. So when we think parabola, think bowl. And this line will continue going up forever in both directions, but that's not really too concerning to us because our lines have always gone forever in both directions. It's just this time they're both going up, which is kind of nifty. And these parabolas are going to be an absolutely amazing tool that we can use in the future. Alright, so I know we're only a couple minutes in, but we're actually doing pretty well here. There's just a couple kind of sample problems at this point that I would love for us to do before I give this to y'all and let y'all run with it. So the first kind of practice problem I want to look at is going to be making sure that we can actually identify this. So trying to figure out how or if something is a parabola. So an example of that would be if I have y plus 7x equals 4x squared minus 6. And to figure out if something's a parabola, all I need to do is solve for y. So to get y by itself here, I'd subtract 7x from both sides. I would end up with y equals 4x squared minus 7x minus 6. If we notice, I have ax squared, a bx, and a c. So I am all good to go is a parabola. An interesting thing to note, sorry that was an example, let me make sure I mark that. A quick note as to if something is a parabola or not is that for my y equals ax squared plus bx plus c is a parabola if a does not equal 0. So I know I put that double F if there. What that means in math is if and only if. You don't really have to worry about that. But it is a parabola if a does not equal 0. What that means is that y equals 2x plus 1 is not a quadratic or parabola. And it's kind of obvious to see that when we look at this. It looks just like these straight lines we've done. And if it's a straight line, it's not going to be a quadratic for us. So we have to make sure that this number right here is not 0, and then we definitely have our parabola. So the other question I got is to try to figure out what direction our parabola is going to go in. So I'm just going to give this one to you, which is if a is bigger than 0, then our parabola goes up. It faces up, which means it looks like that. And if a is less than 0, my parabola faces down, which means it's going to look something like that. So if I have an equation and I'm asked does this parabola go up or down, all I have to do is figure out what term or what coefficient is at the front of my x squared term. And using that, if it's bigger than 0, that means it's an upward facing peninsula. It opens up. And if it is negative, that means it is a down-facing peninsula. So I want us real quick to graph one of these together, and then I will send you all on your merry way. So if I have y equals x squared minus 6x, let's do plus 5 there. I don't actually want plus 5. Sorry about that. Let's see, that's going to give me 9, so I'm going to want plus 8. That ought to work. So if we start off, I'm going to start off at 0, 0. So let me make my xy table, because that's what we're going to want to do for this. xy. If I plug in a 0 for x, I get y equals 0 minus 0 plus 8. So y is 8. So we'll keep looking a little bit. If I plug in a 1 for x, 1 squared is 1, minus 6 is negative 5, and negative 5 plus 8 is 3. If I plug in a 2, I get 4 minus 12, which is negative 8, plus 8 is going to be 0. And I can keep going. If I plug in a 3, I'll get 3 squared is 9, minus 18 is negative 9, plus 8 is negative 1. And I'm just going to continue this a little bit further. So if I plug in a 4, I get 16, minus 24 is negative 8, plus 8 is 0 again. And if I plug in a 5, I'll get x squared is 25, minus 30, and then 25 minus 30 is negative 5, plus 8 is 3. And if I plug in 6, I'm going to get 8 again. If you notice, it's kind of symmetric. I got my zeros right there, 3s, 8s, and this right here is going to be my lowest point. So I'm going to make sure I graph that real quick. And I'm going to start actually at my low point. That's going to make my life a little bit easier. So I'm going to count over 1, 2, 3 spaces and down 1, and that's going to be my first point. Then 1 on either side. At the 4 and the 2, I got a 0. And at the 5 and the 1, I got 3. So 1, 2, 3. 1, 2, 3. And can I fit my 8 on here? 1, 2, 3, 4, 5, 6, 7, 8. Awesome. Way up there would be my 8. So if I connect the dots here, we should be all good to go. And if we notice, our a value here would be a 1, which is a positive number, and a positive number means our parabola opens upwards, which is what it is doing right now. It is facing up. So that's basically how we graph a parabola. That's all you need to know. Y'all have a great day.